Okay, so I think we can get started now. I know we're still missing a couple people, but that's okay. So thank you, first of all, thank you guys all for being here with us tonight. We really appreciate it. We're the Dean's team, so we're all students that were selected to help with the College of Engineering recruiting information sessions. So this is our presentation, just all about what the College of Engineering at Virginia Tech has to offer. Feel free to drop any questions in the Q&A chat, and we will answer those at the end, and we'll kind of go through an overview. And if you're more curious about any of the specific majors that we go over tonight, we do have someone in at least every single major on the Dean's team, and we can connect you guys with someone from that major who can tell you even more about it. So yeah, we'll get right into it. Lily, you can start with this slide.
Sure. So we always like to sort of start off the presentation by talking about what it takes to sort of be a successful College of Engineering student. So firstly, at the very top, we have creativity. And engineering is a field of innovation and sort of yeah, it's a field of innovation. So engineers often need to be creative in order to successfully design and implement solutions for complex real world problems. Then also engineering is very much like a collaborative effort. You'll be working on teams throughout your college experience, especially in engineering, from the get-go in your very first foundations of engineering class, and then all the way through senior year as well. So it's important to sort of know how to work well on a team. And then also having good study habits, knowing how to have important habits like time management, communication, etc., to really help support your academic life. And then an interest in math and science isn't always required, but it does help, especially in your first couple of years, where you'll be taking a lot of those sort of intro math and science courses. And then it's always helpful to sort of have a challenging high school background. This looks different for every student, but what Virginia Tech really likes to see is that you're taking advantage of opportunities that are given to you. So that's if that looks like AP and IB courses, if that looks like dual enrollment courses, sort of having that challenging high school background really sets you up nicely to be a successful engineering student.
So these are just some stats from our fall 2025 class, so the class that just entered. So the average high school GPA was a 4.23 out of 5, and the average SAT math and reading was a 701 and a 687. And again, we like to emphasize that these are averages. So half of this class was above this, half of it was below. So don't use this as like the end all be all of where you need to be because this is definitely a range.
So this is just a high-level overview of our College of Engineering enrollment. Our College of Engineering offers 15 different bachelor's in science degrees, and that are spread over around 12 different departments. So some departments have multiple bachelor's of science degrees. For example, aerospace covers aerospace and ocean engineering, and the ECE department covers electrical engineering as well as computer engineering as well. You can see that our the majors with the highest number of enrollment is general engineering, which accounts for our freshman year class. And then underneath that are mechanical and computer science. They're very popular majors. And then some of our smallest degree majors include mining, material science, ocean engineering, and biological systems engineering as well. So we cover a breadth of different areas of engineering, which we're very proud of.
All right, so kind of what Lily was just talking about. So all of our freshmen, when you first enter Virginia Tech, you're under general engineering. You don't declare your actual specific degree granting major until the end of your freshman year once you've finished those common entry point classes. And we like to emphasize that for building construction students, this is not the case for them. They do not enter under general engineering and they don't have the same common entry point classes as the rest of the engineering students have. So it's a little bit different. But for all other types of engineering, when you first come in your freshman year, you'll all be general engineering and you'll take your common entry point classes. That's 2 semesters of Foundations of Engineering, Calc 1 and Calc 2, usually chemistry and physics, and then 2 semesters of first year writing. We do accept AP, IB, CLEP, and dual enrollment credit. There's a huge database if you look up Virginia Tech transfer credit database that will break down what score on what exam and what class gets you transfer credit for which class. Super helpful for finding out what will transfer. And then we want to make sure that we're raising well-rounded or graduating well-rounded engineers. So something that we have is our pathways for general education. We have 7 different pathways. They cover all different types of areas from quantitative reasoning, like what a lot of engineering covers, to reasoning in natural sciences, like history, art, everything like that. So it's a chance to take classes outside of your major and a really cool opportunity to learn about things that you wouldn't know about outside of engineering. And then at the end of your freshman year, so at the end of general engineering and finishing all of these classes, you get to select your major. And if you have above a 3.0 or greater, you're guaranteed your first choice of major. And then if you're below a 3.0, you can either wait and reapply once your GPA is higher and you'll be guaranteed your first choice major. Or you can apply, and it's based on seats that they have available within each department, and you'll usually typically get your second or third choice major. And for this one, we really like to emphasize that if you have above a 3.0, you are absolutely guaranteed that major. So even if, say, our freshman class of next year, all of them decided that they wanted to be computer science and there weren't enough seats in the department, the university would go and hire enough faculty and book enough classrooms to make sure that there actually was seats for everyone that had above a 3.0 GPA that wanted to be in that major. So you're completely set if you do have it, which is very nice.
Absolutely. So, one of the common entry point in one of the first classes that you'll take is Foundations of Engineering, which is a year-long course. So it's split up over 2 semesters. In the first semester, the course is focused on learning about different ways to solve problems, both like analytically and in like a team. So you learn a couple of different computer programming techniques, data collection, analysis, modeling, and then design tools as well. You learn about different professional skills like teamwork and collaboration and communication. And then you also get to experience and get exposure to a lot of different engineering fields through Exploring Engineering Week, which is very exciting as well. So that's all in the first semester. And then the second semester is devoted to putting all of those skills that you'd learned and developed in the first semester to use, which is done through a semester-long group project that's design focused as well. So you get to design and build your own project according to whatever the professor's like curriculum is. I know from my experience, my team built a musical instrument. I had Dr. Chambers as my professor. It was a really fun project. We got to use the Frith Lab. It was a great experience and a great like exposure opportunity to engineering and what being an engineer could look like in the future.
All right, so now we'll go into some of the different opportunities the College of Engineering has to offer. The first being we do offer several different engineering minors. We do like to emphasize that you can minor across any of the colleges here at Virginia Tech. It's actually very common to. Both of my minors are in the College of Science, not in the College of Engineering, but these are the ones that are specifically offered by the College of Engineering. And a lot of these tie in pretty closely with some of our degree granting programs. Like green engineering is super easy to get for civil and ISC, so industrial and systems. Naval engineering is really easy to get if you're taking ocean engineering. A lot of people in computer science will also minor in cybersecurity. So these are just what the College of Engineering has to offer, but there's so many that the entire university has.
And I will add that like it's very doable to have a major in either one minor or multiple minors as well. I know several members of the on the dean's team have either multiple majors or multiple minors in the engineering department, and they're also graduating on time. So that's also a really nice aspect of it. Another great opportunity is undergraduate research. Around 500 to 600 engineering students usually participate in undergrad research in the College of Engineering. And then these are projects that are potentially sponsored by external like companies and clients that the university may work with. And each project is also supervised by a faculty member that have different like learning outcomes and deliverables that come with the research. So oftentimes these research projects have to do with sort of hands-on projects, as you can see in the different pictures. And then also some of these projects take place at our larger research centers that are outside of Blacksburg. I know that one of our big research centers is the Steger Center that's in Switzerland. So not only are you doing research abroad, but you're also, or not only are you doing undergraduate research, but you also get the opportunity to do that in an abroad setting as well. So a lot of very exciting research going on.
Yeah, and research at Virginia Tech can be done for credit or like to be paid. So you have some flexibility for that. A lot of times undergraduate research will count as tech electives towards your major, which is really nice. Okay, so getting into international experience. So Virginia Tech has tons of opportunities for going abroad. It can be a full semester long study abroad, or it can be over one of our breaks during winter or summer, or there's ones where it's just 2 weeks at the end of the school year. There's so many different opportunities. I highly recommend looking more on our actual like Global Study Abroad Office website, but there are opportunities for within engineering. It's usually within each specific degree program. Like for industrial and systems engineering, I know that we have a program where students can go and study at a university in Brazil, which is very, very cool. But you can also go outside of the College of Engineering. I studied abroad last semester in Florence, Italy, and I went completely through a third party program. I found a university in Florence that I wanted to study at. I found classes that would transfer towards my economics minor and some Italian language classes and got it all approved through the university and was able to go. So it can be very structured through some of the programs that we offer with engineering, or it can be one where you build it your own and make it the experience that you want to have. So there's lots of opportunities. The Steger Center is a really big one that's in Switzerland that tons of people will go to, and it's a really great program. So definitely look more into that, especially once you're into your actual major as well.
I also studied abroad. I studied abroad my fall semester sophomore year, and I also did a third-party program. So the college and university is incredibly supportive of students taking that opportunity to go abroad. So another opportunity that's available to students is the availability to participate in professional societies and engineering organizations. There's around over 1,000 or so and student organizations on campus. These are just a few of some of our professional societies and engineering specific ones. I know I'm personally a member of the Society of Women Engineers. A lot of these organizations are dedicated towards sort of fostering a community of like-minded engineers, making sure that everyone has sort of opportunity exposure to different sort of events, whether that's sort of community bonding events or whether it's professional events as well. I know Society of Women Engineers and then Double ISE, which is the professional like engineering organization for industrial and engineering specific majors. They host a lot of professional events and networking events with recruiters coming in for looking to hire Hokies. So it's a great opportunity to sort of get involved, develop personal skills, professional skills, etc., and to meet other people.
Yeah, I'm an officer in the Institute of Industrial and Systems Engineers, and a lot of these organizations, like we offer specifically a career fair just for ISE students. We have companies that are coming specifically looking to hire our students. So it's a really great opportunity, not only to meet upperclassmen, but also to like get actual face time with recruiters from the industries that you're going to work in. And so many people I know from that career fair that we hosted like got hired right there that week. So it's a really cool opportunity. I highly recommend looking into these once you're in college. Okay, so talking about all that recruiting, these are the internship and co-op experiences that are specific to the Dean's team. So if we were looking at the whole university, this visual would be like 10 times the size. But as you can see, just within the Dean's team, we have so many major companies like Boeing, Amazon, Tesla, at so many more. So this is just everywhere that the Dean's team is interned and co-opted. And one thing we like to highlight is the difference between an internship and a co-op. So an internship is work typically completed during a non-school time. So this is most commonly during the summer, but this can also be like a 4 or 5 week program in the winter, though not as common. Whereas a co-op, you're working full time, but that's during a school time. So it would be during either like a fall or spring semester. And co-ops will typically disrupt your graduation date just because you're working full time instead of taking classes, and you will get credit for doing the co-op, but it's just not the classes that you need to get your degree. But don't shy away from that because of this. Co-ops are a lot longer and are a great experience. I personally have done both a co-op and an internship, and even though the co-op did disrupt my graduation date, it was such a great learning experience, and I never would have had any of the internship opportunities that I've had if I didn't do that co-op. And again, I just learned so much because it was a full 6 months of working, whereas an internship is only two. So I was like fully integrated into my team and learning so much. So great opportunities in both internships and co-ops.
Yeah. I've done two internships, two summer internships. Both were fantastic experiences. Both were through Virginia Tech, where I met alumni from VT and sort of networked my way into receiving like an offer for an internship. So it both great experiences. I know that Virginia Tech is really supportive, which I'll talk about on the next slide. Speaking of all these internships, co-ops, recruiting, Virginia Tech loves their career fairs, especially for engineering. It's a great resource to find jobs, to meet alumni, to network. So the Student Engineers Council at Virginia Tech, the SEC, hosts the largest career fair at the university, and it's also one of the largest career fairs in the country, and it's entirely student led. So it takes place over the course of about a week, and around 300 companies or so come to Virginia Tech just to hire exclusively Hokie engineers. You'll hear this all the time that Hokies hire Hokies. And what's interesting is the middle picture or so, you'll see one girl in like a suit and the other in sort of a maroon polo. And what's interesting about the photo is most people think that the student is actually the one in the polo, but that's actually the alumni. So it really just goes to show like how professional and well-rounded our students are, that they are encouraged to come prepared with resumes and prepared to get hired. And Expo is just one of many career fairs. I know in the spring there's Cameo, and then almost every department or every engineering major will have their own specific career fair as well. I know just a couple weeks ago, there was the Defense Industry Career Fair where we had a lot of companies like Lockheed Martin, Boeing, General Dynamics, a lot of the General Dynamics subsidiaries, so Electric Boat, Mission Systems, all of those. And that was just the defense industry specific career fair. I know there's several for almost every engineering major out there.
Yeah, and Expo is really unique where companies actually do interviews on the spot as well. So this year at Expo, I talked to a company one day, got interviewed in person by them at the end of the week, and then received a job offer the next week. And that's the case for most students that go. So it's a really unique opportunity to not only just be networking at a career fair, but then actually interview as well in like the final part of the week. It's a very cool opportunity, and like what Lily was saying, Hokies love to hire Hokies.
Yeah, and the fact that Expo is so early in the year too, it's just a couple weeks into the school year. So if you are able to get that offer and you're able to get that weight off of your chest so early on, it's awesome. And we also encourage all engineering students to go, whether even they're freshmen or like through all the way through senior year. So
Yeah, absolutely.
it's a great learning experience. Another organization yeah, sorry, I'll let Riley talk about this one.
Oh no, you're good. So one thing that we have on campus for our freshmen is living learning communities. So these are communities of like-minded students that get to live all together in a dorm. So these are just three of the ones that we offer. These are specific to College of Engineering. There are ones outside of that as well. And you can look on the Virginia Tech website. It will detail all of them. So Galileo and Hypatia, or Galipatia, as they're a lot of times referred to, is a living learning community. Galileo for men in engineering, and Hypatia's for women in engineering. They're all in the same building. It's Pritchard Hall. It's in that bottom right-hand photo. But this is for engineers to get to live together. They get to work on all types of assignments together. They have a live-in mentor who's there to help them with resume building, going to Expo, that career fair. They take them and help them learn about everything they should know for how to edit their resume all the way to how to give an elevator pitch to a recruiter. So they have a really good upperclassmen mentoring opportunity with them living in the dorm with them. And it's also great because everyone's an engineering major. So in your freshman year, everyone is taking those same chemistry and calc classes. So if someone's struggling with chem homework, the whole hall probably is, and you can work together. So it's a very cool opportunity to get to know other people that may be in your classes. And they do have their own makerspace. That's that middle bottom photo. That's entirely just for them to use. They have tons of different tools in there, 3D printers, um, like laser cutters, everything like that, and that's available for them to use whenever they want. And then our other one is Digerati. This is an IT focused one. So this is not just specific to the College of Engineering. It can be anyone with an IT mind. So our one of our majors, business information technology, is super common for that. Cybersecurity, computer science, electrical engineering. So it's just for like-minded students that are interested in IT. And that one's also in Pritchard Hall. Just great opportunities to have a community right off the bat in your freshman year.
Yeah. Another way to sort of build that community without the extra added bonus of living with them or living on the same hall with them is peer mentoring. So this is a program that's offered through SEED, and it's one of the oldest programs actually in the College of Engineering, and it's open to all incoming College of Engineering freshmen at no cost. It usually involves around 10 to 13 freshmen are paired up with to one upperclassman that acts as sort of a peer mentor. And they're required to meet weekly for the first 10 or so weeks of the fall semester, and then monthly. And so any kind of like peer support can include like student like exploration, prep for career fairs, resume building, sort of learning about like elevator pitches, learning about the different majors too, especially, and then exposure to different BT academic resources. I know I asked my peer mentor a lot about what classes to take in the spring when course request was coming out and what teachers that she liked and everything like that. So it's another great opportunity to meet like other like-minded peers in the College of Engineering, and then while also making connections with someone that might be a little bit older than you, and then get some sort of advice and experience from them too.
Yeah, I was a mentor or a mentee and then a mentor in this program. It is so great. It's really low commitment, which is really nice. So you can always sign up for it. There's no cost to you. Anyone's welcome to join. And if you decide you don't want it, you can just tell your mentor, say, hey, I'm going to stop coming to meetings. And they're like, you're not required to show up. So it's really low commitment. I highly recommend it. My mentor, my freshman year, I ended up going into the same major as her. I did one of the study abroad programs she did. And then she was recruiting back at Expo this most recent year. So I was able to go up and talk to her about that. So it's really nice. And I had the same experience when I was a mentor. It's a very cool program and it's a good way to just feel more comfortable being in the College of Engineering and learn about things that you may not learn about if you didn't have like that upperclassman who was helping you along the way.
Definitely.
Okay, so then another support program that we have is our Student Transition Engineering Program. So this is a 4-week program that typically happens in the end of June, early July. So you actually come to Blacksburg and live on campus. You get to do tons of fun activities, and you also take some of those common entry point classes that freshmen take. So it's like Chem, Calc, and Foundations of Engineering. It's not for grades that are going to count, but it's just so that you can see the curriculum, get used to what some of the course load may look like. And that way, when you come in as an actual freshman in the fall, you will have seen the first like 3 to 4 weeks of content, and you're just so much more prepared. So this is really geared towards students that want that extra support of transitioning from high school to college and getting used to the college life because you'll be living in dorms. And again, even though you're taking classes, like they're doing tons of fun activities with you. That upper middle picture is the Venture Out course. It's a ropes course on campus. You get to go there, get to do all different types of activities, see the drone park in the bottom right-hand corner. So it's really, really good if students need that extra support from making that transition as smooth as possible.
A common phrase that you'll hear around campus is hands-on, minds-on. So the VT College of Engineering really believes in sort of learning through hands-on experiences. And one of the ways that you can do this is by like looking around in our first year makerspace, which is home to over 30 undergrad lab assistants, and then engineering students from all years across the College of Engineering. And any general engineering student can use this lab once they've completed all the like required safety modules, and it's a great space. I know you can take like classes and learn how to make different things. Um, and you can use the lab for different projects, like I mentioned earlier, that first year engineering foundations class, you can definitely use the Firth lab to help with that project and with other design projects that may come down the line. And if you're ever on campus, it's in room 170 of the new classroom building. And it's just a really cool space that you can look around.
All right, so another lab is our Wear Lab, and this houses a lot of our design teams. So these are teams where you can actually get to build super cool things like the car, the that's Formula SAE in the upper right-hand corner. They completely build this car and then they actually race it, and they usually compete nationally as well. We have tons of more ocean-focused ones like human-powered submarine or the auto boat or design, build, fly. That's very aerospace focused where they're actually building an airplane. Baja and Bolt are both motorcycles, so you can get very involved in these and learn hands-on mechanical engineering, industrial, like every type of engineering is applicable here, but you get to see how they're actually applied in the construction process for building these things. And you can also get credit if you're on these design teams, which is very cool. We highly recommend checking out the Wear Lab. It's in the old military building. If you look up Wear Lab and when you're on campus, you'll be able to find it and you can walk right in. You can see the design teams working. They each have their own bay. And these are just very cool opportunities to get and experience of actually like seeing your engineering principles being applied outside of class.
These are a couple more engineering design teams that we have. These are all teams that are in the Advanced Engineering Design Lab. So that's a little bit off campus. But this is, again, just a few of the teams. I'm personally on a team that's not listed on here. It's called the Degree Dues at Virginia Tech. I've been on it for 2 or 3 years now. We compete nationally and against like international teams as well. And a lot of our design teams are like, they're actually pretty good too. I know our concrete canoe team is really good. Our steel bridge team is really good. I don't mean to brag, but my team is also pretty good. We're back-to-back national champions. Um, but yeah, so not only like are you able to sort of learn in this sort of great multidisciplinary space, but you're actually able to sort of apply the skills that you've learned in class while also learning new skills that you may not have learned in your major. And then while also being able to sort of compete and show up and like support your school and your team, which is it's pretty awesome.
Okay, so just some numbers. So from the US News and World Report, we have the number 2 building construction program and the number 14 undergraduate program, and as well as the number 31 graduate program. And then for the American Society of Engineering Education, we're the number 7 producer of engineers for a bachelor's degree. So just some numbers that we're pretty proud of. And these are just the specific ones from those 2 reports. There's tons of reports out there. Feel free to go ahead and look. I know that a lot of our individual departments rank pretty high as well. ISE is usually in the top 5. I think we were
We're top
2
4 right
last
now.
year.
Yeah.
Oh, wow. Okay, good. Okay, good. And like other ones rank really high as well. So it again depends by the actual engineering program, but great numbers that we're super proud of.
And then another sort of just like by the stats overview, our engineers are wanted once you graduate. So this is just kind of like a high level overview in 2024. So over 85% of our freshman engineers end up staying on after freshman year, which is really important. We want to make sure that we're supporting our students and that they actually want to continue in their degree course after their freshman year. And then after graduation, only around 60% of the graduates responded. So of the 60%, around 66% are employed, and then 19% plan to attend some further sort of education or through like grad school or other like further education. And then if you look out like 6 months, like post graduation, these are just like upon graduation, those that are employed, etc. If you look like 6 months out after graduation, these numbers actually are higher too. And then sort of our median starting salary for Hokie engineers is around 78,000 or so. So not only are our Hokies being hired, but they're also very successful too.
And one thing we like to note about that freshman who continued on to a second year in engineering, if they're in Galileo or Hypatia, that number jumps to about 98%. So it just shows that having some level of support for getting through engineering in your first year is a really big factor in whether or not students stay. So we're really proud of that stat for Galileo and Hypatia. Okay, so scholarships. So we have the General University Scholarship application. This is one application that applies you to all available scholarships at Virginia Tech. It's really nice that you don't have to do a lot and you don't have to be doing a lot of supplements. And then you just have to submit that as well as the FAFSA to be considered for scholarships. And then for transfer students, we have a shared application. That's due June 1st. And that's usually, those are the two names of the scholarship. It's usually a pretty big scholarship. And then for upperclassmen, so the way that Virginia Tech is structured, actually, once you get into your degree granting program, there's typically more funds housed at that level. So once you get higher into your education, like sophomore, junior, and senior year, students tend to actually get more scholarship money because they're actually in their program. So again, you just submit the General University scholarship application to FAFSA every year. It's only one application. It's due in the winter. And then you're open to both College of Engineering funds as well as those departmental scholarships, which is where students tend to get a lot more money from, especially as they get higher up in their education. So it's really nice that you don't have to be applying to a lot of different scholarships to be considered.
And then it's November, so Christmas is right around the corner. We like to usually bring this up because oftentimes high school grads often receive their college computer for Christmas or early on before they come to Virginia Tech. So the College of Engineering is a little bit specific about the types of computer that students should have. Basically, we really just want the computer to be able to support heavy software like CAD and SolidWorks, etc. So we usually don't recommend a MacBook for our freshman engineers. And so this QR code is constantly being updated. I know this slide was updated in around September, so I'm not sure if the requirements have updated since then. But through like the QR code, you can easily check to see the computer requirements. So yeah,
Yeah, and for this, because they do change quite a bit, we do recommend if you can, making this laptop probably a graduation gift, not a Christmas or birthday gift, just
yeah.
because those requirements do change. So if you can, wait as long as possible to make sure that you have the most up to date, especially in majors like mechanical or aerospace where you're running pretty heavy software. It's going to be pretty specific based on what your laptop needs. So yeah, just if you can, wait and make sure you have the most updated requirements for your laptop before buying.
Definitely.
Okay, so now we'll get into some of the engineer or all of the engineering majors that we have to offer. So the first one, okay, we're going to talk about the next three are electrical engineering, computer engineering, and computer science. The way that we like to think about these three is a spectrum. So electrical engineering is all the way on one end of the spectrum. This is mostly hardware focused. So all of those different types of concentrations you're seeing on the screen, controls, robotics, autonomy, energy and power electric systems, nano systems, wireless communications. That's very hardware focused. Computer science, on the other end, is very software focused. This is all about coding and programming and machine learning. And then computer engineering, which we'll talk about next, is kind of where the two meet in the middle. So that's how we integrate our software that we're coding with the hardware of the actual computer and things like that. So electrical engineering is more on the hardware side. Electrical engineering is really applicable in all of our design teams. That photo in the upper left-hand corner is Bolt. That's an entirely electric motorcycle. So very cool team that they get to build this and race this. So electrical engineers are very popular for all of our teams, and it's a great major to learn everything about wireless communication signal processing, which is everything that we use in our world today.
So, like Riley sort of said a little bit earlier, computer engineering is sort of where electrical engineering and software and computer science sort of meet in the middle. So, oftentimes, computer engineers often learn how to embed electrical systems into software systems so that they can be used by users. So, computer engineering often covers a lot of stuff, areas like integration, controls and robotics and autonomy, as well as machine learning and cybersecurity is also really popular. I know a lot of computer engineers often pursue a cybersecurity minor as well. And then there's a fair bit of software too. So you get to learn, it's great exposure to both fields as well.
All right, and then getting into computer science, again, this is pretty software focused with human computer interaction, knowledge, information, and data, scientific computing, systems, and networking. It's one of our biggest majors on campus. It's been the fastest growing within the last couple of years, and it's a very cool opportunity to learn all about how software works, especially with the growing field of AI. Computer science is very applicable for that. And something really cool that our computer science department offers is hackathons. So that bottom left-hand corner, that's two students at a hackathon. They're very popular and not just limited to computer science majors. I know a lot of people that participate in them, and they're so much fun. And then in that upper left-hand corner, that is one of our virtual reality systems, which is super cool. We have that on campus for CS majors to use.
And then on the other hand, one of our other most popular majors is mechanical engineering, which is one of the broadest engineering majors. You can really kind of go into any field that in engineering that you would like to after graduation, whether that's in the automotive industry, whether it's in design and manufacturing, energy, nuclear, robotics, and mechatronics as well. It's a great major if you're sort of unsure where exactly you'd like to go post graduation. And I kind of briefly mentioned robotics and mechatronics. Also, the shorthand is RBMT, but it's sort of a specialized major within mechanical engineering that you can sort of choose to do if you want to focus on sort of that sort of like specialization. And then, like Riley said, there's a lot of engineering design teams. Mechanical is a very popular major for a lot of these design teams. For example, like the hybrid, like the EV car, which is in the bottom, the picture in the bottom left corner, and then the Baja SAE car, the Formula One team. And then what's a funny, sort of a funny story is the upper left corner. There's a tradition at Virginia Tech football games where after every touchdown, this is back when we were good, but after every touchdown, the cadets would have to do as many push-ups as we had points on the board. And our mechanical engineering team department felt very bad for these cadets because, again, at the time, they had to do a lot of push-ups. So they actually built a robot that would come out on the field during the games to do the push-ups for the cadets. So they got a break. So yeah.
All right, so aerospace engineering. This major is very similar to the next one that we'll talk about. That's ocean engineering. And the reason they're very similar is because it's studying how things move through liquid, just two different liquids. One is air and one is the actual water in the ocean. So for aerospace engineering, you learn everything about aerodynamics, flight dynamics and controls, structures, space engineering, and vehicle design. It's a very, very popular major, especially with how much of defense recruits from us for aerospace industries. So it's a great opportunity to learn everything involved in aerospace engineering. And again, a lot of design teams are aerospace focused. We have design, build, fly. We have the NASA student launch team. There's tons of teams that are involved. They get to use the drone park that's in that upper right-hand corner to do a lot of their testing for their vehicles before they go to compete. And then we have a small airport here where aerospace engineers can go as well. That's in that bottom left-hand corner. And then a super kind of funny anecdote for aerospace engineering, that upper left-hand corner is the photo of a Rolls-Royce engine hanging in one of our buildings. If you ever come for a campus tour, I highly recommend checking it out. It's in Goodwin Hall. It's just like hanging from the ceiling. It's very cool. But so this engine was too big to fit through the front doors when they had built the building. So they had to take the top off to actually lower it in place and then suspend it from the ceiling. And then recently, I think a couple of years ago, Rolls-Royce asked if they could have the engine back, and we had to tell them no because we would have had to take the top off the building again, and that would not have been good. But our aerospace engineering program is a great department, tons of opportunities to get involved and learn all about aerospace engineering. They have really good job placement as well.
Yeah. And then very similar, actually in the same department as aerospace engineering is ocean engineering. So ocean engineering deals with a lot of like design of ships of all kinds. The field's often called naval architecture as well, and involves sort of fluid mechanics, propulsion, structures, and vehicle dynamics, and marine engineering as well. And then and actually, if you complete the ocean engineering degree, you actually you get to build your own like complete ship by the end of the program, which is really awesome. And then, so we have a couple of different naval engineering teams. We have Concrete Canoe. We have Human-Powered Submarine too is another really popular team on campus that's also very successful as well. So it's pretty similar to ocean engineering. I actually hear that it's pretty common to double major in ocean and aerospace engineering just because there's only a couple classes of difference. So yeah,
All right, industrial and systems engineering. So, and this is my major, so I think it's the best, but
we're
it's
both biased.
subjective. Yeah. So, for industrial and systems engineering, there's no concentration that you can declare, but these four listed here are kind of the main areas that you'll take classes in. So, human factors, engineering, ergonomics, that's all about like how do we make the workplace safe for a human, as well as things like the technology that we interact with, like cars, how do we make those user interfaces safe? And then management systems and manufacturing systems, a lot of this degree is understanding how we interact with systems and how systems can be improved. So, process improvement, things like Six Sigma and quality control, you learn all about that. And then operations research as well. This is similar to systems, but understanding just how things work and how we can make things better and faster in every sense of it. I really love this major because it takes a little bit more into like the human impact into engineering. We kind of consider engineering with like a business consideration, where it's how does human impact, how does technology impact humans, as well as how do we impact it, and how can we make it better in terms of more productive, but also better and safer for people. So I really love this major. Again, we're one of the top departments in this major in the country, so it's a great opportunity. There's tons of undergraduate research opportunity, especially with ergonomics. We're always trying to understand how the human body works, but it's a really cool field, a really great program.
Actually, sorry if you don't
Oh
mind
yeah,
cutting
go
in.
ahead.
One of the pictures is like in the bottom left-hand corner is our industrial and systems engineering lab. So if you end up going into ISC, I think around your sophomore year or so, you'll take a manufacturing processing lab where you actually get to learn how a lot of the tools and processes that are used in factories in manufacturing settings actually work and function. So almost sort of learning inside a factory, at least manufacturing wise, on your way, like working your way backwards, like to like a bigger picture overall. And this was one of my favorite classes. You actually get to learn how to weld for a couple of weeks. You learn how to stick weld, and then you also learn how to use a robotic arc welder. And I know this is pretty special. I don't know a lot of schools that sort of where you get the opportunity to do this. So it's pretty awesome.
Yeah, that lab was so much fun.
It
That was
was
one of my
so much
favorite
fun.
classes.
I still have my project from it.
Oh my gosh, I do too.
Another pretty popular engineering major on campus is chemical engineering. This is actually one of our most highly researched engineering areas. There's a lot of research in chemical engineering where students learn to sort of creatively apply principles of chemistry, biology, biochemistry, math, and then also physics to solve problems involving many like different areas in so specifically our energy, food, health, electronics, and then consumer products, and then also environmental quality as well. There's a lot of yeah, so you learn about chemical impact on humans and vice versa in a variety of different settings, including like the manufacturing setting as well, which is incredibly relevant, and especially in regards to manufacturing sort of sustainability and health and safety for workers as well. So a very relevant, important field.
Yeah, one of my favorite design teams is actually the photo in the upper left-hand corner. It's called Chemi Car. They go to competitions, they get unknown ingredients, and they have to make a chemical reaction. They get a specific distance that they're told to make the car travel. So they have to like assess what they've been given and then figure out how much of what to put into this chemical reaction to make the car actually travel the correct distance. No idea how they do that. I think it's so cool. So chemical engineering is very cool. You just for this one you do have to like chemistry, just like a note that we like to say. You'll take a lot of chemistry because that's
Yeah,
what it is. So
you
make
do
sure
have to
you
take
like
organic
chemistry.
chemistry too.
Yes. Okay, so the next one is kind of similar to chemical engineering, where it's a little bit more chemistry focused. So material science and engineering. This is like engineering the materials for their intended purpose. And you work with tons of different materials from biomaterials and ceramics to composites, electronic materials, and polymers. So a little bit more of that chemistry focused side. It's a very cool department. It's pretty small, but it's very cool. Material science and engineering touches everything that we use in our daily life, like things like how can we make a material super strong but super light so it fits the specific design specification. So it's all about optimizing that. And they get some really cool opportunities for hands-on learning. There's a foundry on campus, that's that bottom right-hand corner. That's actually only open to material science and engineering students, and they get to use it to learn. I think they may even use it for some of their classes. And I do know that some of the class rings actually come from the foundry on campus. I don't know, it may just be for material science and engineering students, but either way, they're the only ones that get to use this. So it's a very cool major. And so one little anecdote we like to say that this helps me understand what they do a little bit better. But so that football photo in the upper left-hand corner kind of seems unrelated. But so again, back when we were good at football, we were in a bowl game and one of our star players had been injured. So his left or his right wrist was sprained and he was just going to wear a brace because he was well enough to play in the game. But the brace was actually deemed a weapon on the field by the officials, and he was not going to be allowed to play because of the size and bulk of it. Would be a risk to himself as well as to the other players. So they brought in the material science and engineering department, and they explained the whole issue to them. The material science and engineering department developed this like sling or brace that's on his wrist in that photo. It's that black thing on his forearm, and it's strong enough to prevent him from re-injuring the arm or the wrist, but it was not rigid enough and not bulky enough to be considered a weapon on the field. He was actually allowed to play in the bowl game, and we probably won because this was back when we were good, and it's not the case right now, but that's okay. But that was a really cool opportunity for the material science and engineering department to really make an impact on the field, and also just like a really cool example of how their work is used in day-to-day life.
Speaking of day-to-day life, sorry, it's sort of an engineering field that touches our lives like in every day, is civil and environmental engineering. So this is another incredibly like broad field, where civil engineers are the principal like designers, constructors, operators, and then caretakers of a lot of the constructed facilities and systems that sort of contribute to um, a lot of the structures that we deal with on a day-to-day basis. So maybe that's roads, bridges, tunnels, highways, anything almost involving transportation or land development or construction often involves a civil or environmental engineer. This is also a field that has to do a lot with sustainability, so super relevant right now as well. A lot of focus on like water resources as well. In fact, the picture in the bottom left corner, one of our civil engineering professors was actually one of the first professors to help uncover the water crisis that was happening in Flint, Michigan, at the time, and helped either, and sorry, not either, but he helped uncover the issue and the crisis that was happening, as well as helped fix sort of make plans for to redesign the infrastructure in Flint to sort of fix the crisis and to help recover what was happening at the time. So there's a lot of engineering design teams too that are associated with civil engineering, the steel bridge design team, and then as well as, oh, there's another one. I'm totally forgetting it.
Concrete canoe is the one in the bottom
Yeah,
right-hand corner.
concrete canoe as well, where they make a canoe out of concrete that floats and that races. Insane. But
I don't
yeah.
know how they do that. That one is so cool.
Mhm.
Okay, so our next major is construction engineering and management. So a little note about this major and then building construction will be next. This is an engineering major, but they're both housed in the Myers-Lawson School of Construction. Building construction is not technically an engineering major, so that's just like their separate college that they're stored in, but it's like a smaller umbrella under the umbrella of the College of Engineering. So construction engineering and management this is actually an industry requested degree. So we asked companies like, what do you think of the engineers that we're producing? Is there anything that we're missing? And industry companies actually said this is like a major thing that we're missing and this is something that we need. So they have a really great job placement because this is one of the best programs and this is one that they specifically asked for. But this is all about teaching engineers how to to be a good manager of construction projects. So, how to design the project in a smart way, as well as construct it in a sustainable way, focusing on human-centered construction issues and as well as project management. So, it's building that person who can be the high-level overseer of any type of construction project, managing things like the resources being used as well as the people being used. So, this is a great major for entering construction at kind of a higher level than as an actual construction worker. You're more on the management and design side. There's tons of construction going on campus. We're always building new buildings, so there's ways for them to get involved all the time. And again, they have a really, really great job placement rate because it was an industry requested major.
So on the other end of the industry requested major is building construction, also in the Myers-Lawson School of Construction. This one is not engineering, so if you go into building construction, you won't complete the first time in college, like first year engineering courses. So you won't do foundations of engineering. You'll just sort of jump right into building construction classes, which is pretty cool. So while CEM is focused on like sort of the human-centered part of construction projects. Building construction is more focused on sort of the design and implementation of those plans. So it's a lot of focus on innovation, emerging technologies, sort of business and other construction management skills, and then the creation of sort of vertical structures, spaces, and systems to sort of support those plans. Um, so our BC students are incredibly like well employed as well. At also at graduation, it's always easy to spot the building construction students because they'll have hard hats at graduation, which is pretty fun. But yeah.
Yeah, building construction has 100% job placement rate, and upon graduation, they've typically completed 2 to 3 internships. So this
Out
is
of
one of our
yeah.
highest job placements in the university.
Oh, and both of the majors are like you complete classes in Hit Hall, which is one of the newest buildings on campus. There's a dining hall also in Hit Hall. And those classrooms are really cool. There's a lot of really cool construction labs that are going on. There's like a mini crane in one of the like classrooms. It's where our 3D concrete printer is held as well, which is really cool to walk by and see.
All right, so one of our smallest majors, but very, very cool, mining and minerals engineering. They have a great faculty to student ratio, so you get to learn a lot from industry professionals. But mining and minerals engineering is kind of more of a sustainability focus to how do we go about mining. Mining, while it may seem like an older industry, is certainly not going away. It's so crucial for so many of the technologies that we use. So it's all about learning about critical minerals for new technologies, mine safety and miner health, how we can make it better through green engineering and pollution control, as well as focusing on carbon capture and storage and energy production. So it's all about how to make both mining safer for the miner, but as well as for the environment. It is a crucial industry, so we need to make sure that we're trying to go about mining in the best way possible for sustainability. So it's very applicable major. And for mining engineers, because it's so small, so I don't know if any of you guys have visited Virginia Tech yet, but so if you look at all of our buildings, it's all covered in the same stone. It's called Hokie Stone, and it's all mined from the same quarry. I believe it's in Virginia. It may be West Virginia though.
Yeah, it's in Virginia. It's
Okay.
like 20 miles-ish away, I
Okay,
think.
cool. But all the mining and minerals engineering students actually get to go to this quarry and they get to take a piece of Hokie Stone with them, which is so cool. No one else gets to do that because it's all being put on our buildings. But it's a very cool opportunity. And again, they just have such a great program with how small it is and all the teachers that they get to learn from and the real world experience that they have as well. So many of our students get employed working in mines and getting to see how their actually mining is completed. And there is a mining building on campus where they have like a simulated mine that students get to use all the time, which is very cool.
I have a couple friends in mining and material in MME, just because we're all in the same engineering team, and it's crazy that like they just all know each other so well. It's like such a tight-knit community. And then the internships that they talk about are it's insane, and the amount of responsibility also that the interns get to have on sort of different mining projects is it's really cool to hear about. So second to last is biological systems engineering, so which connects biology and engineering together to solve complex problems affecting us in the areas of sustainability, environmental protection, human health. Graduates of the program often develop like engineering like solutions that help protect like our land and water resources. So you learn a lot about biotechnology engineering, environmental health, food, watershed science, and then also like health professions as well to sort of not only like help protect our like land and water resources, but also the people that are working in those different settings as well. So a huge focus on sustainability, which is very cool. It's also a big major for research as well.
Yeah. And we do have a really cool team in BSC, so that upper left-hand corner. I forget the name, but they do dirt judging, and there's like a contest where they receive a sample of dirt and they have to like evaluate it and make an assumption or estimate where they think it came from. And that's our photo of our team that won the national championships a couple of years ago. And I'm sure they're still just as good to this day. So very, very cool team. Okay, getting into our final major, biomedical engineering. So one thing to note, biological systems and biomedical engineering can both be pre-med tracks. So if you do want to go to medical school after, both of these degree programs can set you up for that. So biomedical engineering is all about applying technology to the human body through biomedical devices and imaging to biomechanics, cardiovascular engineering, nanomedicine, or translational cancer research. So it's very applicable and tons of research going on in the biomedical engineering department. We have a really cool lab on campus called the Helmet Lab. So they actually do testing and evaluating of different helmets for different sports. They have rankings online that they post and they show which ones are best at reducing concussion risk. I'm taking a class in that department right now, and it's been so interesting to learn about. It's a really cool lab, and a lot of biomedical students will get involved in the research going on in that lab. Um, so it's a very cool major to learn all about how technology gets applied to improving the human body or human health in tons of different ways. In that upper left-hand corner, this is another example of research going on campus. This is students with our Blacksburg Rescue Squad. So this is student-run rescue team actually figuring out how to design this bed to put patients into the ambulance with minimal disruption to them. This is super important. If anyone has some type of injury where they shouldn't be like rustled getting into the ambulance, is super important for making sure that that device can actually lift them without disrupting anything of how they've been set with their injuries. So it's a very cool department with tons of research opportunities for students.
So that sort of concludes our section about the all the different majors that that exist in the Virginia Tech College of Engineering. If you want more information, you can scan the QR code. It'll take you to a website where you can sort of explore the different majors in fuller depth. And if you would like any more information about specific majors or like any student experience, we on the dean's team we do have a student at least one student from each major on the team, so we can absolutely get you in contact with someone who may be able to speak to a little bit more about that experience. So if you're open to that or if you're looking for more information, please feel free to throw that into the chat box.
Sorry, messed up those slides a little bit.
You're good.
But yeah, okay. So for how we like to end our presentations is giving our why we chose the College of Engineering at Virginia Tech. I can start. So I don't know, I forgot to say, but I'm from Boston, so I didn't really know much about Virginia Tech when I was applying. I just kind of knew that I wanted to do engineering, and my guidance counselor told me that it was a good school, so I should apply. I applied and didn't really think that much of it because I just didn't know much. And then when I came and visited, I came in like my spring break in April of my senior year of high school, and it was the worst weather ever. It was like hailing outside, it was freezing, and it had like just been warm, but I loved the campus even in the terrible weather. It was so beautiful. It just blew me away, and I had like zero expectations. That may have been part of it. And then even in this terrible weather, the thing that like really struck home with me was how nice everyone was. Like my mom and I were walking around the campus wearing our little like visitor badges, and everyone was coming up to us being like, "Oh, is there anything I can show you? Like, do you look lost? Do you need to find a dining hall?" Like everyone was so open and so welcoming, and that was something that was super different for me to experience at a university, especially while it was hailing out in like 20 degrees in April. So I loved that part. And then I came to a College of Engineering session just like this and hearing about all the opportunities opportunities that they had to offer and how it seemed like there was something for everyone here. That's what I really loved. And I can say that the people part has held true. All the people here are so great. It's really made my last 3 years. So that's why I chose the College of Engineering.
Yeah, a lot like Riley, like I came here and I fell in love with like all the people and just like the vibe and energy on campus. It's so exciting, especially like in the fall, especially like as the leaves are changing and football season's happening. It's the energy on campus is it's insane. And another reason why I chose to come to this, specifically like the College of Engineering, was when I was looking at colleges, something that was really important to me was that I could feel like I was supported at the school. Like it wasn't an extremely competitive atmosphere, or I felt like I was gonna drown and like I was just gonna drown in like all the weed out classes or stuff like that. And I feel like everyone at VT is so driven towards like making sure that you're successful, whether it's the faculty, your professors, your TAs, etc., whether it's your advisor, whether it's your friends in the class as well. Like there are so many people around that want to see you succeed, whether that's academically, social wise, career wise, etc. Everyone's really driven towards like making sure that you succeed and that you feel like comfortable and supported. So yeah, absolutely. So with that, we'll open it up to some questions.
Yeah, I
Um,
saw we have a couple in the Q&A bar right now. So the first one is if students have credits for multiple common courses from AP, IB, when can they choose their major? So this is a great question. So for this one, if students come in with like a lot of transfer credit, there is an option. So that Foundations of Engineering class, it's typically 2 semesters, but they can take a condensed one that's instead of 2 credits across 2 semesters, it's 4 credits in 1 semester. And then if they take that and they have all the required credit, so chem, calc, physics, everything else that's required by their degree to declare their major, then they can declare at that end of their first semester freshman year. So you just have to make sure that you have those credits and take that condensed class. So yeah, if that answers your question, feel free to ask more questions. We're happy to do that.
Yeah. The second one is asking if GPA requirements differ for different majors and fields. I know for that like specific for the freshman engineering one at where like you need the 3.0 to guarantee your first choice. That applies across the board for all 15 majors. A 3.0 and will guarantee you your first choice in your major. Um, so I hope that answers your question.
Yeah, and if you're asking for like fields like for working, it really depends on the company itself. Most companies do have a minimum GPA requirement for internships. It's usually like above a 3.0, and depending on the company, if it's like a really competitive company, I've seen some as high as like above a 3.4 or 3.5. So it just really depends. Some don't even have a GPA requirement. They won't look. So it just depends on like the type of company and the field that you're looking to get into. And then so the next one is what are the eligibilities or requirements for scholarships for freshmen? Are scholarships available for out-of-state and immigrant students? Yes, absolutely. Scholarships are available. We highly recommend you apply. There isn't like a specific requirement that will be listed. There's tons that are fit for different students that are applying. We usually have scholarships that will cover all different demographics the students are coming from. So like absolutely apply. There will be available scholarships.
Yeah. Another question asks if the fee structure is varied based on different majors and fields. This is not something like I'm not sure if Riley and I can speak on this. I would recommend reaching out to sort of the financial aid office with this question, or someone at the engineering office as well can probably help you out with this.
Yeah, absolutely. All right, so the next question is, other than GPA, what is mandatory for admissions process? SAT, ACT scores mandatory for general engineering. So we're a test optional school. That's not required. For more admissions questions like that, we're definitely going to refer you to admissions. We can really only speak on like what the College of Engineering has to offer, but for the general university and what they're looking for, I would reach out to admissions. They're, I'm sure, more than happy to answer any of the questions that you have.
And then the next question is asking if cadet students often have difficulty balancing engineering. I know that there's a large percentage of cadets that are in the College of Engineering. I see them all the time in my classes. Um, but I personally can't speak to sort of difficulty balancing. I can try and reach out if you would like for one of us to reach out to someone in Dean's team to see if they're on the if they're in the core. Um, Let me know. I would reach out to the email that's in the chat that I dropped, and we can definitely try and find someone
I do
to.
think it's typical for Corps of Cadet students to take 5 years if they're doing engineering, just because they do have classes they have to take for the Corps of Cadets as well. And engineering is usually a pretty full 4 years, so it's hard to fit extra classes like that. So I do think it's not out of the ordinary for them to take 5 years, but definitely refer to like a secondary resource for. Okay, so my school does not offer physics subjects. Can I still apply for general engineering or mechanical engineering? Yes, absolutely. Like what we said in the slide about challenging high school background, like we understand that not all high schools provide the same opportunities. So we're just looking for you to challenge yourself within what your high school has to offer. It's totally okay if your high school doesn't offer physics. I didn't take AP physics, and you can absolutely still apply. Like, do not worry about that. Just apply to what you're interested in.
Yeah, I can speak to the same. Like I took IB physics. I still took physics one and physics two here at the university. So it really just depends. And the school and admissions understands that it looks different for everybody. Um, so yeah, that was all the questions we had in the Q&A. Are there any more out there? Again, if you'd like, this session was recorded, so if you'd like to, oh, we have one more question. But if you'd like to have a copy of the recording, I encourage you to reach out to the email that I dropped in the chat. It's engrrecr@bt.edu. And then the last question that we'll take is, as a large, like in a big engineering school, how do you manage like large lecture classes? This is actually a great question. Especially like freshman and sophomore year, you'll probably have a lot of larger lecture classes, and then as you sort of move on as an upperclassman, you'll have sort of some smaller classes. Um, I found it always easier, sorry, to like your first couple days of classes, just like say hi to the people next to you, make friends in your classes. They'll help get you through. Other resources are the professors, the TAs. Each professor and TA will have their own office hours. Go to office hours. Go to office hours as much as you can in person, especially your freshman and sophomore year. It's just such a great way to get to know your professors, how they teach. It's oftentimes like helpful, especially as like exam weeks come near. They'll often like help you out in terms of what's going to be on the exam, what won't be, structure, etc. Office hours are such a great way to sort of get involved and sort of like to like I've never regretted going to office hours, long story short. Yeah.
And Virginia Tech does a great job of making sure that you're not in that many large ones. For a lot of your core classes, like all the math classes, I've never been in a math class bigger than 30 people. They know that that's really hard, so they make sure that you're not in a big math class. The only classes that I've had that have been like true typical college large lecture halls are chemistry and physics. And for most of those classes, they also have recitation sessions. So that's a separate time that you meet. It's usually required for the class as well. You meet in like it's groups of like 30. You do group focused problems every single week. So you're like in a group of 4 people. And it's a great way to make sure that you're actually applying what you learned in the lecture that week. So those recitation classes is also with a TA. So it's another way to meet the TA and get to know them. So I think Virginia Tech does a great job of like trying to limit how many times you are in a class like that. And they make sure that you have the opportunities to be in smaller group settings like those recitation classes where you get to actually like be working with TAs and with other people too.
Yeah. Another one asks about the ISC program and how big it is, and then do you offer on-campus placement opportunities for students after the program? Yeah, so the industrial engineering program is around 500 students across all undergraduate classes, so sophomore, juniors, and seniors. And then we also have around 130 graduate students as well. ISC has a great graduate program. And I know that you can also do the like the 4+1 program where you start your graduate classes in your senior, like quote, senior year of undergrad and then finish your master's degree by just adding one more year. So you graduate in 5 years with a bachelor's and a master's, um, which is pretty great too. And for campus placement opportunities for students, um, I know there are like opportunities available. There's a lot of like research like placement available as well, like especially if you're a grad student as well. And yeah. Um, I think that's all. Thank you so much for attending. I hope you enjoyed. Again, reach out if you have any questions or would like any further information. Um, yeah.
Yeah, thank you guys so much.
I think we stopped.